In this episode, I want to share with you a simple node tree. Basically, this is a case of the rolling default cubes. I've done this in the past, but this is like I'm doing it using just geometry nodes instead of SVerchok nodes. So this is just the default cube. Each one of them is rotating and rolling procedurally, and I can play around with the speed. I can play around with the scaling of the cube itself, as you can see, and then I can offset the time. So if I look at it from the side view, you can see the cube can have different size, can have different rotation speed, and they're rolling, but they will always stay on top of the floor. Okay, this one is rotating pretty fast somehow. Okay, so you get the drill. So what's going on here? Let's take a look very quickly. We have these 3 different geometry nodes. The first one actually doing like the rolling. So let's take a look. Sorry about the noise suddenly. The first one is doing the rotations and also the scaling. And all of these attributes will be unique for each object. But they are all just the default cube, okay? So the first one, it's keeping the geometry, which is just the default cube, but I can easily replace it with Suzanne or whatever different geometry that's coming in. So you can see we have a scaling happening. Scale goes into this transform node, and we have these rotations, and the rotation is basically a time value that's being offset using add and also being multiplied, and so as a result we have this procedural rotation. The second geometry nodes will actually do the hard job. This one is checking the bounding box, finding the minimum and the maximum, and then get the height, subtract the height, and then multiply it by half. So we have the center of each object here. So there should be like some kind of bounding box that we can observe, just to keep these objects always on top of the floor, no matter what. Okay, so the third one actually, from the second one, I'm actually piping out the result of this bounding box as a vector, and I call it blah. And from this blah, you can see this value is being used to set the position of each object on top of the floor. So capture the attribute called blah and simply use it as a position offset for our objects. So everything works properly. So if we create another geometry nodes for an object, for example for this guy, if we create another geometry nodes and if we replace this with other object like a cylinder, for example, it should magically like work. So the object will maintain its position on top of the floor, which is like it's quite magical. It's pretty weird that this actually works, but yeah, you can play around with the speed, with the time offset for the rotation. So with the, if we make like a duplicates, if each one of them have a different time offset, and then if you use it in the as a collections, you can actually have quite an interesting animations. So all it's doing is just rolling procedurally. I can change the scaling, and it should update accordingly, so it will always maintain itself on top of the floor. A more complex example will be like if it's doing the rolling on a different type of surface. Currently it's just like rolling on the floor, but I think it's pretty it's pretty okay. It could be improved, so it will take all kind of objects. Let's see if I duplicate this, if I delete this object and then replace it with monkey, I think it should work also, as long we put it on the ground. Oh yeah, I think the center pivot. Okay, set origin to geometry. So this is more or less it's working. I can scale Suzanne and expecting it to be, most of the time it should be on top of the floor. So you can feel free to make modifications so it works with things like text objects or whatever, but in general I really want to give you this example to work on the default cube. So this is the default cube. Feel free to scale it, scale in X, Y, and Z, and it's gonna update itself. It's gonna do all the calculations to make it so it's always on top of the floor, and then you can put it into new collections and call it boxes, and then so you can have a floor plane, and you can have all this dancing cube on this floor. So instance on points, we can distribute some points, and we can grab something from collections. We use it as instance, and then we scale the instances. So we have all this rotating cube. We're gonna pick the instance object randomly, random value, so we can have all this dancing cube. Let me see, I think, yeah, okay, we need to separate the children and reset the children so they are now in the proper position. We can increase the density. They are all still rolling and dancing on the floor. Perhaps to make this more interesting, we can use combine XYZ. We can use the rotations and simply use random value for the rotations, and minus pi and then pi for the value. Okay, save it. If you want this to be stable, plug in the stable ID into each of these objects. So that should generally what's gonna make this complete. If you want to have, okay, if you have multiple version of this guy, we can have different scaling, but maybe use the Poisson disk and increase the distance so we have each one of these objects have its own space. So there you go. This is the final result. Rolling and dancing animated cube. Alright, so hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.